Today, we're going to talk about another transformation called a reflection. A reflection is a transformation that uses a line, like a mirror, to reflect an image. Think about flipping an object over a line. The line you reflect over is called the line of reflection. Oops. And sometimes we abbreviate that as LOR. So that's the abbreviation for line of reflection. Now, the image and pre-image are the same distance away from that line of reflection. So if we look at this example here, we're going to say, okay, where is the line of reflection? Well, let's count the distance from A to A prime. 1, 2, 3, 4, 5, 6. So halfway between those 2 points is going to be right here. So this is our line of reflection because we are 3 units away from that line when we look at both points. That was x equals positive 1. X equals positive 1, same thing. Now, if the point B is negative 4 comma 5 is reflected over the same line, where is B prime? So negative 4 comma 5. So here's B. And again, we have to count how far away. 1, 2, 3, 4. So we have to go 4 units on the other side. 1, 2, 3, 4. Here is B prime. And the coordinates of that point are 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So 5 comma 5. And if we have point C at 1 comma negative 1, 1 comma negative 1, so that is right on the line of reflection. So if we were to reflect that, it would stay in the same spot. 1 comma negative 1. The point stays there. So this was point C, and it is also C prime because our point is on that line of reflection. Now remember from Algebra 1 that vertical lines have an equation x equals some number, so an up and down line. That equation is x equals a number. A horizontal line that has the equation y equals some number. So the line goes left and right, that's horizontal, that's y equals a number. Let's look down at example number 2, where we have triangle DEF, and then we're going to graph that triangle, and then we're going to graph the reflection over the given lines. So let's plot 0 comma 2, here's D, 1 comma 4 is E, and F is 3 comma 1. So here's the original triangle. And we have the same thing over in letter B, so let's plot that real quick for letter B. D, E, and then F. Okay, so we have our picture drawn for both examples. Right, for example A, it says the line y equals 2. So let's find the line y equals 2, which is right here. So y coordinate of this line is at 2. And then we're going to reflect a line. Well, since point D is on the line, D prime would stay where it is. And then E is 2 units above the line of reflection, so we gotta go 2 units below the line of reflection. So here would be E prime. Point F is 1 unit below the line, so we're going to count 1 unit above the line of reflection, and that's F prime. So then our new triangle looks like that. Now in example B, our line of reflection is x equals 4. So on the x-axis, we're going to go to positive 4. And that is my line of reflection. And we're going to count. So point D is 1, 2, 3, 4 units away. So I'm going to count 4 units on the other side. So that is D prime. For letter E, I'm 3 units away. So count 3 units on the other side. That is E prime. F is 1 unit away, so we go 1 unit on the other side. We have F prime. So that is our reflected image over the line x equals positive 4. Now let's look at the next page. We're going to reflect some things over the x and y axis. So we have L is negative 3, 3. M is 1, 2. And N is negative 2, 1. And we're reflecting over the x-axis. So here's the x-axis right here. That is our line of reflection. So we'll go ahead and count with point M. We gotta go 2 units below. So here's M prime. And the coordinates of that point are going to be 1, negative 2. Now for N, we're 1 unit above, so N will be 1 unit below the line of reflection. And the coordinates of that point, that is negative 2, negative 1. And L is 3 units above the line of reflection, so we're going to go 3 units below the line of reflection. And that's where L prime is. And the coordinates here for that point is negative 3, negative 3. Then for part B, we're going to have the same triangle from the original problem. So let's plot that real quick. L, M, and N. And now we're going to reflect over the y-axis. So here's the y-axis. And let's count. L is 3 units away. So L prime would be right here. And the coordinates of that point are positive 3, positive 3. M is 1 unit away from the line of reflection, so we go 1 unit on the other side. Here is M prime, and the coordinate of that point is negative 1, 2. And then finally for N, that point will be over here, and here's N prime, and the coordinates of that point are 2, positive 1. So here's the drawing of my reflected triangle. So if we look at these points and then the reflected images over the x and y axis, look at the x-axis first. All that changed was that the y value changed signs. So the y value was positive 3 for L, and in L prime it was negative 3. Positive 2 became negative 2. Positive 1 became negative 1. So when I'm reflecting over the x-axis, the y-coordinate changes signs. So for x-axis, y-coordinate changes sign. And then when reflecting over the y-axis, the x-coordinate changed signs. So we have -3, it became +3. +1 became -1. -2 became +2. So when I reflect over the y-axis, the x-coordinate changed signs and the y-coordinate stayed the same. So y-axis, the x-coordinate changes sign. So you can write that as a rule down here. If the point AB is reflected over the x-axis, the x-coordinate stays the same, the y-coordinate changes signs. If the point is reflected over the y-axis, its image is the point -a, +b. So these rules will make life a little bit easier when you're asked to reflect over the x or the y-axis. The last rule that we're going to talk about is about reflecting over the line y equals x and y equals -x. So if reflecting over the line y equals x, is a and b, they're going to switch places. So it's going to become b, a. And if we're reflecting over the line y equals -x, the coordinates are going to switch places and change signs. So let's finish these last two examples where we are reflecting over the line y equals x and y equals -x. So we have a is 3, 2, and b is 4, 1. So here's a segment, and we're going to reflect over the line y equals x. The line y equals x is a diagonal line that goes to the origin and has a slope of 1. So this is our line of reflection. And if I'm reflecting over the line y equals x, I'm going to switch places for each coordinate. So a prime will become 2, 3, and b prime will become 1, 4. And then we can graph that. 2, 3, so here's a prime, and 1, 4, there's b prime. So you can kind of see if you were to fold your graph over this pink line, the two segments would lie on top of each other. And then for letter B, if we're graphing the reflection of the line y equals -x, we saw the same points. So 3, 2, and 4, 1. And the line y equals -x goes to the origin and has a slope of -1. So there's your line of reflection. And the rule for that is you take the x and y coordinates, you switch places, and you change signs, either from positive to negative or negative to positive. So a would become -2, -3, and b prime would become -1, -4. So -2, -3, so there's a prime. And here is b prime. So again, if you were to fold your paper over that green line, the segments would lie on top of each other. So I hope that reflections made a little bit of sense. It's all about drawing a picture and counting and remembering to use the rules. So make sure you have these out while you are working on your assignment.